This DVD has been produced by the New Zealand Ministry of Health. It provides information on the pathogens and pathways of contamination that can affect small drinking water supplies. Drinking water is usually safe in this country, but not always. It has been shown that most urban supplies in New Zealand, in medium and large cities, have safe water, better than most parts of the world. In small supplies, this may not be the case. There can be germs in drinking water, bacteria, viruses and protozoa. These are microscopic organisms that can't be seen by the naked eye, but which can cause serious illness, and sometimes even death. It doesn't take much for a water supply to become contaminated. A dead rat in a water tank or a cowpat in a river can make many people who drink the water sick. This is why keeping a community's water supply safe to drink is vitally important. Someone has to work hard at keeping the bugs out of the water if the system breaks down, or if someone doesn't do their job properly, or if the water is not being treated at all, then the results can be disastrous.
There was an outbreak of enteric disease. About 3,500 people were affected, and the
town pulled their water out of a lake, which is filled up with people running around in boats. And on the sides of the lake, there's a whole lot of people living in houses with wastewater. The wastewater is pumped up along the lakeshore. One of those pump stations failed, so sewage ran into the lake. Unfortunately, it failed right where the pump taking water out of the lake was, so they pumped some dilute sewage around. And most of the town, particularly most of the children in town, got diarrhea-type illnesses, vomiting diarrhea.
You may think that your water's safe. You may never get sick because you've got an iron guts like me. But I tell you what, it's a different story for our tamariki and our kaumātua. If they're getting sick, you know you've got a problem. And we had a situation at our marae a few years ago where some of our manuhiri got sick. And some of the people on the committee said to me, oh, it's the water's making them sick. I says, it's not the water. People have been drinking that water for years. And they eventually convinced me to go up and check the stream, and when we went up there was a dead cow in there. Never bothered ever checking in before, but what we found that day made our visitors sick. It's part of our traditions, our tikanga, to look after our visitors and to make sure that they're well and healthy. But because I didn't check, they got sick. So what I'm saying to you is that you got to make sure that your water is clean and is pure, not only for your visitors, but for your kids, for your tamariki, for your kuia, for everyone. It's not worth risking it at the end of the day. It's just not worth it.
One of the major sources of water contamination is bacteria. Bacteria are single-celled organisms. Bacteria have been around for a very long time, appearing on Earth 400 million years ago.
Most bacteria don't really affect us at all. It's not that all bacteria are bad. Hey, doesn't harm us, we don't harm it, it's got nothing to do with us. You know what I mean?
And actually, a lot of bacteria are really good.
Well, I guess
because they can actually help digest food in your intestine.
And you've got that bacteria on your skin.
Yeah, and the good bacteria can actually keep the bad bacteria at bay.
Really?
Yeah.
Oh, okay.
And there's actually only really a small group of bacteria that are really harmful to humans.
And they're the pathogens.
Yeah, like Campylobacter.
Yeah, I had Campylobacter. That was terrible. And Shigella and Salmonella.
Yeah, Salmonella.
And Salmonella Dub, it's a band, eh? And Shigella sounds like a girl's name. Hey, this is my daughter, Shigella.
If people get me through their mouths and into their guts, I will work in about, say, 18 hours there or thereabouts to make people sick. People are more likely to get diarrhoea, and so we can really cause very, very nasty illness. And effectively, I'm attacking the inside of your gut.
And did you know if you took all the people who ever lived, not just the people who are alive now, but everyone who ever lived, did you know that you've got more bacteria in your mouth than that? And 1 single gram of faeces, you imagine that? You hold a single gram of faeces in your hand, there are 1 trillion bacteria, not to mention a dirty hand. There's the fecal oral route. Who's the scientist who worked that out? Did he wash his hands? They're the largest population on Earth. There are billions.
Dennis, you really need to find a new hobby.
Where are you going? Come back.
Hi, I'm Campylobacter and I'm a pathogen.
Hi,
Hi.
And how have you been doing this week?
Well, it started off okay, but I got on some kid's fingers, and then I got into his stomach, and then I was in his kind of gut, and I just couldn't help myself. I started multiplying.
It's all right. We're not here to judge. Tell us what happened. Did you try the exercises?
I did. I tried the breathing exercises. It didn't really work, really. I tried, and I tried to stop myself from multiplying. I tried it, but I just couldn't.
What happened? Can you tell me what happened?
Okay, well, when I'm in a place that's moist and warm, and I'm so lonely I could cry through cellular division. I start to multiply. Given conditions that are favorable, every 20 minutes we will subdivide. 1, 16, 32, 64, 128, 256. Okay! I said 512. I said 1,024. I said 2,048. I said 4,096. 8,192. 16,384. We're going to multiply through your body. We'll multiply exponentially. We'll colonize your intestine. We'll make you sick. We'll make you nauseous. We'll give you diarrhea. We'll multiply, 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 multiply.
Protozoa are also single-celled organisms, but they are a lot larger than bacteria.
You don't need to swallow many protozoa to make you very sick. They multiply like a bacteria and can completely line the insides of your gut, which means that the body can't make use of the food you eat. 2 common protozoa are Giardia and Cryptosporidium.
Yeah, well, I'm a protozoa, and one of my favourite places to hang out is in the intestine, in the animal intestine. Cows are one of my favourites, and I just hang out in there, and then the cow pops me out. I'm in the cow pat, and the cow pat starts to cool down, and I don't like an environment that's cool, so I go into my cyst state, and that protects me there. It can protect me there just sitting on the soil until I'm picked up by another animal, hopefully a human, and then it only just takes one of me to get down into the digestive system, and I can replicate. And then what may happen is the intestine might expel me after a period of time. And I'm quite difficult to get rid of, but eventually I will be passed through the digestive system, end up back in the soil again in my cyst state.
We interrupt this program to bring you a special news report. It appears that protozoa have entered the intestine. Can you tell me what's happening at the moment, Wendy?
Yes, Jim. Protozoa are much larger than the bacteria, as you can see behind me. It's really quite scary, and they're eating the bacteria. And it seems like they're multiplying. Yes, they're multiplying now, Jim.
So what's going to happen next, Wendy?
Well, Jim, the protozoa are going to attach themselves to the intestine wall, and they're going to completely line the intestine so that no food can get into the body. They're going to make our host very sick indeed, Jim.
So are there any good protozoa, Wendy?
Well, not for humans, Jim, but in the human body, they can be deadly.
Why is the news always so bad? Why can't we change the channel?
Viruses are much smaller than bacteria, and they can be harder to kill. A virus is basically just a simple package of DNA or RNA that reproduces itself by integrating into the host cell and making copies of itself.
The waterborne viruses that we recognise as potential problems in New Zealand are norovirus, that's a virus which can cause diarrhoea. There's hepatitis A, hepatitis A virus, which causes liver disease, and that's a virus which survives very well in water and is recognised almost entirely as being waterborne. There's also adenoviruses. Now, these are a range of viruses that are often associated with recreational water and swimming pools, and they can cause throat infections and eye infections, and some of those cause diarrhoea and gastroenteritis as well. And the other group of viruses are the enteroviruses, and one of the examples there is poliovirus, which is a virus which can cause paralysis and meningitis and heart disease, liver diseases, all sorts of horrible things.
Water can be contaminated by human viruses when there is human waste discharged into it, so that's fecal waste. And viruses can be harder to kill with chlorine than bacteria.
And the other difficulty with viruses, that, especially with the waterborne ones, is that they're so small they can pass through filters.
Helminths are worms that live in the intestines of animals and humans. The tapeworm is a common helminth. Helminths are much larger than bacteria and protozoa. In fact, some are up to 1 metre in length. The eggs of a helminth, which appear in urine and faeces, can be accidentally ingested by a human. When it hatches, it will grow into a worm and live in the human body as a parasite. Because they are so large, tapeworms can physically block the intestines.
Yeah, they're a major source of disease in some countries. Because
They're not in New Zealand. They're not.
No.
We don't have a problem here, but
That's
yeah,
right.
in other countries they are a major source of problem, health problem.
Yeah, serious health problems.
Very serious.
Cyanobacteria is the name given to a group of organisms that live in colonies. They live in water, and like plants, they produce their own food through photosynthesis. The reason we have so much oxygen in the atmosphere is because cyanobacteria produced it billions of years ago. It is also known as blue-green algae, though it's not actually algae.
So the problem with cyanobacteria is they produce a range of natural toxins that we call cyanotoxins. And those cyanotoxins are obviously a health risk to humans consuming that water or even having just contact with the water. A couple of cases in Brazil, one in 1996 when a hospital's water supply became contaminated and dialysis patients received this contaminated water, and I think 56 of them died from complications associated to it. You had another case in Brazil where a water supply became contaminated and 88 people died. So, yeah, there are some quite serious cases of it. And in Australia, another incident where a dam had experienced a big cyanobacterial bloom, and they treated it with algicide, which actually causes the cyanobacteria to die, which lyses the cells and releases this massive pulse of toxins into the supply. And in that case, I think they hospitalised 150 children. So.
The fecal-oral route refers to any way that fecal material can enter into the human digestive system. There are many ways this can happen, such as a person not washing her hands after going to the toilet and then eating food, or a farmer milking a cow, picking up bacteria off the cow's udder and then wiping his mouth. Fecal contamination can then pass into the mouth, and bacteria or protozoa can then enter the gut and start to reproduce.
Well, it was a long, dry summer, and there wasn't a lot of water around. It started to pour down with rain one day, and I thought, well, I'll just get a big bucket and whip round the back when it was really pouring down, and stuck the bucket under it, and I thought, great, and just that's the water that I drank that day. Until at about, 5 or 6 o'clock at night, I thought, uh-oh, and I had to rush off to the loo. Diarrhea, and felt like giving birth. Really, not that I know much about giving birth, but yeah, it was pretty hard out. And I was told there were rabbits on the roof, but there were actually rats, and there was a lot of rat poo around. I know that, so that wasn't very good. And birds, probably actually predominantly birds. Yeah, a lot of bird pop up there.
Yeah, well, we've all been sick for months, And this health guy came along and he said he went up the back and had a look at the farm, and he said, look, here's the pipe, where your water's coming from, and all these cows are crossing the river up there, and that's floating down the stream and going into your water pipe, and now you're drinking it. That didn't even occur to me. We didn't even think about it. We were just turning the tap on and drinking the water, and so we just moved the pipe about 100 metres up the stream above where the cows cross, and we've been right as rain.
Well, we went and we bought this house in the country, and it was really nice.
It was more than nice, and it was more of a cottage than a house. And yes, you remember?
Yeah. The neighbours, the neighbours above us had a septic tank, but all their water was going, all the stuff from the septic tank was going into our drinking water,
and it was draining into what we thought was beautiful spring water, and it was draining all his effluent,
and it was making us really, really sick.
And of course, it was filled with, poos, nasty bits, and we were sure it was pure. And there we were busily drinking it and encouraging the children to drink more of it when it was contaminated.
Oh, okay. Well, no, we just woke up one morning and the whole the whole tribe sort of were starting to feel sick in the stomach, and we ended up by 10 o'clock in the morning. We had them all at home, vomiting, diarrhea, and all that sort of stuff. And well, I don't know. We had to trace it back to somewhere, and we realised the day before we were out. Filling the feeding troughs, water troughs with the hose and stuff like that, and something happened. Oh, yeah, that's right. Yeah. We left the hose. You drop the hose in the trough, turn it on, go away, do something else. Meantime, the pressure had dropped, and all the water from the troughs had got sucked back up through the system and into our drinking water, and that's what the kids were drinking. So were we, for that matter. So we're all out to it.
Backflow occurs when contaminated water is sucked back into the water supply when water pressure drops.
The other problem is backflow, where if you have a system where somebody is using the water in such a way that if the pressure in the main water system drops, water can be sucked back into the mains. This can spread organisms. We had a case in the zoo when the people were mixing up an arsenic weedicide. And again, they left the hose in the tanker they were mixing up the weedicide in. There was a pressure drop, and one of the workmen He was drinking some of the water later on. He died of arsenic poison.
When we test water for contamination, it would be very expensive and time-consuming to test for every possible kind of bacteria, protozoa or virus. Instead, we test for just one bacteria, E. coli.
E. coli is a bacteria which is found in human and animal excrement. Excrement.
Well, E. coli is found in faeces and fecal material, so if we find it in the water, it means that the water, of course, has been contaminated with fecal material.
You know, for drinking water, you want no bacteria. You want no E. coli. E. coli indicates that there is disease-causing organisms. There may be disease-causing organisms in the water. So you want your drinking water to have no E. coli?
Well, first, we make sure that the water is the right temperature. And then we add the media to make the bacteria grow. And then we shake it up and we leave it in the incubator for 48 hours. Now, this one here is clear, so it's a negative result. Now, this is a positive test. And when we put it under a UV light, we can see the fluorescent glow, which indicates that E. coli are present. This means that the water is contaminated and may contain other pathogens. And this is just one of the ways we test for E. coli.
We need to make sure that when people turn on a tap to get a drink of water, that there are no bacteria, no viruses, and no other pathogens. Even a small number of pathogens can have a huge impact because they multiply so easily. Just one germ can become 10 million in a short space of time. This is why the treatment of water is vitally important. Everyone should be confident that the water they drink is absolutely safe.